All right, then over to our final speaker before the lunch. Now you have to apologize if I don't pronounce it correctly, but I would say Homan Bigdoli. Wow, that's perfect. So Homan is a product line manager at Nokia with over 16 years of experience in relevant areas. So I think we will show that in your presentation. We will see that in your presentation.
Thank you very much. Okay, so my name is Human Bitgoli. I'm the quantum safe network lead on the Nokia IP MPLS site. And I guess what we're going to talk about in the next 20 minutes, I hope until now you guys have been scared enough from quantum safe networks. That's to our advantage. And the second scary part is me being between you and the lunch. I try to make that as smooth as possible. But with all the seriousness, I was in the MPLS track and I was talking about Cloud RAN. And one of the things that came up is we do have a lot of type of network out there. We do have wireless networks. We do have vertical business, critical infrastructure, gas, electricity, federal, etc., and data centers. Each one of these networks has its own transport requirements. As an example, data centers, fat pipes, 400 gig, going to 800 gig, there's a lot of talk of that. That is layer 2 or IP. When it comes to the wireless network, they like slicing. Fiber is sometimes scarce, and they want to create multiple slices, different services, business services, wireless services over the certain network. Critical infrastructure, they like MPLS, segment routing. They like fast recovery, FRR, and they like the fact that MPLS brings traffic engineering into the network. And of course, federal, well, it's a mishmash of different transport, IP, MPLS, but again, they do like the fast recovery, traffic engineering that comes into the network. Now, going through some of these networks, here's an example of a wireless network. As you can see, when it comes to wireless network, it comes as an enterprise flavor, and it comes as the transport that operators, tier 1 operators in North America, in CALA and APAC, EMA, they deploy. When it comes to pure wireless network, you can have an MPLS transport, again, for slicing, or in some of these vendors, they use IP transport, flat IPv6 in the base routing. When it comes to the enterprise, they like to go over the ISP because they don't have the fiber or the transport infrastructure. Different flavors of network, different requirements from transport point of view. What we've been seeing is that governments for IoT are beginning to utilize these networks to bring critical infrastructure through the wireless 5G, 4G into the light of the day to bring those kind of services up and running. Critical infrastructure, if any of you out there have been in the business for the 5-10 years, means encryption. Like it or not, 5-6 years ago, we went through this very scare that suddenly a certain government said, if you are doing critical infrastructure, gas, utility, you need to bring encryption into your network. And oh my God, there was such a panic. These guys were using MPLS. They needed to go to encryption. MACsec was not the sexy thing 5-10 years ago. They wanted to bring IPsec. They were asking us how to go from MPLS into IPsec, and that was a quiet churn into the network. There was no easy solutions back then to switch from an MPLS transport with all the goodies into the IP transport. So going to quantum, when there's an MPLS network, you're going to have the same type of problems. Here's a critical infrastructure. Again, as I said, just explained, MPLS is a biggie there. And if you want to go to encryption, you got to start thinking, what do I need to do? Do I need to go put extra money into hardware that does MACsec, low latency, high throughput type of encryption? Or do I need to go purely into IPsec? Luckily, now we have SRv6 that brings traffic engineering and fast recovery into the IP world. You can actually have those USEEDs, microseeds, or legacy seeds to bring traffic engineering into your IP network. So maybe SRv6 is the example going forward, or maybe they want to stay with MPLS going forward. Here's a layer 2 lease provider. Again, we've seen a lot of layer 2 lease providers trying to bring services to the federal and critical infrastructure. Some of these critical infrastructure networks, they don't have the fiber. I mean, they try to put fiber so they can build their own network, but sometimes where there's, digging is impossible, New York City or, some of the bigger cities throughout the world, they want to use leased infrastructure. Leased infrastructure means you need to bring security, encryption, quantum safe into those leased network. And it is not just bulk encryption. Let me be very, very clear. If you are bringing security into this kind of leased network, you want each customer, each slice to have its own key. As it was mentioned, symmetric keys, AES-256, that each customer can secure their own slice via their own keys. Army doesn't like to share a key with the hospitals or the police. Air Force, the same thing. They don't like to share a key with Navy. Everybody wants to have their own keys. So you need to make sure when it comes to signaling those AES-256 keys throughout the network, you can signal per customer, per slice. All these transports, different encryption type, is a nightmare, at least in my opinion. I've been through it for 12 years. I've been trying to bring encryption into MPLS network, changing them to IPsec network, seeing the panics throughout the industry. It is a nightmare. You have IPsec that is doing IKE. You have TLS that is doing its own certificate PKI. I have no idea why IETF didn't go with one single protocol for all these technologies, transport or layer 3. And then you got MACsec that is doing MKA. Each one of them trying to negotiate keys for their datapad encryption in its own way. Now, I mean, as my colleague in Juniper, I don't see him around anymore, kind of mentioned, is there is this try in IETF to standardize at least pre-shared key, symmetric key distribution through IETF, and I fully support that, seeing the pain with TLS and IPsec. But is there a solution even today that we can create quantum safe network, simple encryption, security that fits every single network with a single protocol and a single key distribution out there? And that takes me back to MACsec, as everybody has been talking about. MACsec is great. Why is it great? Because by chance, they didn't want to follow IETF. They wanted to come up with their own key distribution. And again, by chance, because they are not IP-centric, they took the next best thing instead of using PKI, and they used symmetric keys for key distribution. That AES-256, that is quantum safe, is being used for key distribution and datapad. That means that you need to configure that pre-shared key on both routers. But as it was mentioned, after you configure that pre-shared key, your network is quantum safe. You can sleep soundly throughout the night knowing that your network is quantum safe. The team, and the sexy word here, AES-256. That's what quantum safe network is all about. Now, another part is how do you generate that entropy? We've been hearing a lot that when it comes to entropy for quantum safe, 256-bit. Everything is 256. I don't know why. I guess quantum computers have problems with 256. 256-bit of entropy is the key. NIST, FIPS, NIAP, AEL3, all these certifications are saying your entropy has to be 256-bit or better. What is entropy? Entropy is the distance between the same key being generated twice. So it's the randomness of the key generation. That's what entropy is. So you can get that entropy even with MACsec on the data path and on the pre-shared key through QKD. They generate enough entropy to do 256. As I mentioned a couple of questions ago, is beautiful. QKD is there. What about the certification? If you want to sell it in North America, how do you get the FIPS certification, NIAP certification? EEL3 might be the way to go, but certification is very important when it comes to QKD. The next best thing is when it comes to the data path, the routers itself. So until now, throughout the industry, the routers or the switches have been generating entropy for MACsec, IPsec on the CPU or on the hardware that is sitting on the router. So if you do generate that entropy, 256 on the router for your data path, and you can secure that key via pre-shared key, which I'm not going to get into. I think everybody else got into the pre-shared key, how they can be distributed. You can secure that entropy of 256 via your pre-shared key, and you advertise it to the other end. Now your data path is quantum safe. Your entropy is generated on the router. You don't need to buy any extra hardware as mentioned. You just need to figure out how you will generate randomness pre-shared key within your network, and you're good to go, at least from MACsec layer 2 point of view. Another thing I mentioned with MACsec is per customer keying, per customer service. Each one of these customers, they want to have their own keys. In MACsec, usually it's bulk encryption. You go encrypt the entire 400 gig, you go encrypt the entire 200 gig, low latency, high throughput encryption via MACsec. But there are technologies out there to bring per customer service even into the MACsec technology. One of the things that we do at Nokia is we have MACsec per VLAN. So what that means is, think about a layer 2 network, leased network, that each VLAN represents a customer. We can actually identify a VLAN, create a MACsec session specifically on that VLAN, and the MKA that is being signaled to signal the AES-256 key can be specifically writing that VLAN too. So we call it per VLAN MKA, brings customer awareness, a slicing awareness into a layer 2 network per customer. Pre-shared key, again, I'm not getting too much into it. I think we kicked that cow all the way to death. But there are different methods of doing pre-shared key. One of the things that we use in Nokia is our Nokia SMS. It gets connected to the router via SNMP v3. SNMP v3 uses AES-256. Keep the theme, 256, to connect the SMS to the router. It has a hardware security module, generates the keys, pre-shared keys, AES-256, downloads it to the router, manages it, rotates it. Everything is simplified. So eventually, we can go to QKD as well. It can get hooked into the SMS or into the router. Seamless pre-shared key management throughout the network. So that part of it is obviously taken care of as well. Now, MACsec, we accomplished. It's quantum safe. It's got the right key distribution, the right data path encryption. Is it the right technology for layer 3 and MPLS? The short Answer, yes, it is the right technology, given the fact that you can decrypt at each router, make a layer 3 decision-making, MPLS decision-making, encrypt again on the egress, and every router within your network needs to be MACsec capable. That's a lot of money you guys need to spend in your network to take out all your routers, put MACsec capable routers to bring quantum safe networks into your operation. Is there another way to solve the MPLS and IP quantum safe dilemma with another type of technology? So the first two packets that you see, that's MACsec that I already talked. The standard already says that when it comes to the VLANs, it has to be encrypted. Only the SecTag, which identifies where the key is in the stack, and the source destination MAC is in clear. The second packet that you see is eventually somebody came, and I think it was Cisco, by the way, and they said, hey, wait a minute, I'm going into a layer 2 lease network, and it's VLAN aware, VLAN is per customer. How the heck am I gonna solve that problem? I'm doing bulk encryption. How am I gonna bring this encryption per customer? So not via a standard, they said, well, why not go put the 802.1q tags into clear? Now, I looked at the standard IEEE 802.1ae, and I don't see anywhere that there is any sentences that says, hey, by the way, you can put the tags into clear. Somebody did that. Everybody said, great, I love it. And then, Microchip and, Broadcoms, they went and they implemented, and here we are thinking that VLAN in clear is part of the MACsec standard. Great ideas. Sometimes you don't need standards. So we took it one step farther. We said, well, when you bring the VLAN into clear and you use the MACsec engine to encrypt it with the VLAN in clear, and you don't run authentication over it, so that means that you can swap, pop, remove the VLANs, manipulate them as you will throughout the network, why not put the label in clear? Why not put the IP header in the clear? You have an MPLS network. You already have solved, as you've been hearing, the fact that MACsec is quantum safe. We are saying use the MACsec engine. Just put your MPLS label into clear. What is that going to give you? End-to-end MPLS network encryption that is quantum safe. Put your IP header into clear. What is that going to give you? SRv6 end-to-end that is quantum safe, or IPv4 end-to-end that is quantum safe, same protocol, same encryption engine, same hardware. Now you can encrypt multiple layers of the OSI throughout your network. All right, wonderful. How do I identify an MPLS or an IP flow within my network and encrypt it via the right key, customer key? Same thing as layer 2. There is a CAM for MACsec that identifies the source destination MAC that you lock on and you encrypt. There is another TCAM that logs onto the VLAN per VLAN MACsec and you encrypt. We put a layer 3 lookup engine in there, and we are able to log into a specific source destination IP or a specific label stack, and we can encrypt MPLS or IP with its own specific key. So Army can have its own key, Navy can have its own key throughout the network. Now we took care of MPLS, IP, MAC, all with the MACsec engine. Every customer has its own quantum safe key throughout the network. Your network is quantum safe at all layers of OSI with the same technology. How do we signal these keys from one MPLS router to the other MPLS router? Let's go reinvent the wheel. Well, wait a minute. There is already a protocol that does that for MACsec. It's called MKA. can we reuse the MKA in a layer 3 network? Yes, we can. All you got to do is, as it turns out, put an IP header on it and a UDP port to identify it as an MKA packet through the network. That's it, that's all. So if you want to encrypt from PE1 to PE3, when it comes to your MKA, and I'm trying to look here, yeah. So when it comes to your MKA, all you do is that you put your source IP, dest IP, that is PE1 as a source, PE3 as a destination. You put a UDP header that we are trying to standardize that UDP header, a well-known port. Right now it's configurable. You put the UDP header in the network that every single router in the network identifies that UDP port as MKA, and you shoot these MKA packets throughout the network, and the routers that are each end of the MPLS encryption use MKA with the MACsec engine to grab the SAC, program the data path, encrypt the MPLS, SRv6 flows, and off you go. So now you got a single network, single protocol, single key distribution that can lock into the PQD, whatever type of key distribution that you have, to bring quantum safe network into your operation from layer 2 all the way to layer 3. So here's our end-to-end type of topology. And one thing I want to add here is that one thing I've seen, especially with federal networks, is they do not like that packet in clear on the router. They don't like the fact that you come in with MACsec, you decrypt, and there is, 7 microsecond or 7 millisecond of clear text packet in the fabric of the router before you encrypt again and you go out of the other port, right? So to them, while some of these routers are sitting in the wild, that 7 microsecond is still a point of attack that they want to close. They want end-to-end encryption. And I've been to the extent of having conversation with federal networks that they want double encryption, meaning that they want on that access router not to terminate the MACsec, they want an EVPN there, that the MACsec goes all the way to another CE router through a layer 2 network, and they want a second method of encryption on the PE in the middle. You can do that with MACsec and AnySec. You can have that LSP that is connecting the two PEs encrypt at the MPLS layer with the MACsec engine, but you can have the CEs doing MACsec over a EVPN or a VPLS over that LSP that is already encrypted all the way to the end of the other CE. SLA. You guys might say that, all right, fine, all these stuff are handy and dandy. I already designed my network. I have a certain SLA, certain fast reroute requirement, recovery requirement. I do not want to blow away those SLAs. I don't want my throughput through the network to go from 400 gig to 300 gig. Anybody in the industry that does MACsec can tell you that latency throughput for MACsec is negligible. We did some tests with MACsec, and you can see the latency for clear text and the latency for when the packet is encrypted. It's nanoseconds. It doesn't bring any latency throughout the network. That's why MACsec is really applicable to low latency type of networks. Since it's the same engine for AnySec, MPLS IP encryption, same latency will apply when you're encrypting your MPLS, SRv6, or IP network, transport. Last but not least, so we have already cooked in the MACsec engine into the NPs. These MACsec engines can start encrypting at all OSI layer. When it comes to the key distribution, we are not pre-shared key distribution, symmetric key distribution. We are not reinventing the wheel. We are using the technology that has been proven for the past decade, MKA. We are just putting it over IP. We are working in IETF, again, to try to see whether this MKA over IP UDP is something that we can bring into the industry as a whole solution for symmetric key distribution. And when it comes to the latency and SLAs, we feel that you don't need to worry about when you bring in these quantum safe encryptions into your network, because really MACsec engine doesn't introduce any hiccups to the SLA or the latency of the networks that you guys have. That's all I got. Hopefully it was helpful to you folks.